Hey, it's John and Mike, brew-use.com. As you can see, dry January is doing great. This isn't vodka. This is actually, I was watching as we were prepping for this video, I was like singing a little song going, Science with Mike, Science with Mike. So we are going to test out parts per million of sodium
chloride, table salt.
Table salt in... And I saw you building this in front of my eyes. We're going to work from our right to our left. This is the control. This is straight up spring water.
Spring water.
And then you're going to test my threshold.
Yes, we're going to test our threshold.
For flavor, because each of these has a different quantity of table salt in them, and it's almost like when we get here, it'll be like, can I taste the salt or not? So
to use scientific terms, this is a titration of sodium chloride. Okay, so the one on the far right, you can just go ahead and sample it. I know you're dying of thirst. The one on the right, this is just plain spring water. So adjust your palate.
Okay.
That is effectively your zero. Oh, it's nice and crisp. That's good. That's effectively your zero, although spring water isn't zero. But I know that this source of spring water, we're talking about single-digit values for these things. But for this experiment, it doesn't matter because we're building on top of it. So we go from that to this next one. And maybe for this, I won't tell you the total ppm here until you... What the deal here is that go ahead and sort of work through them. When you... I'm just curious when your flavor threshold will hit the sodium chloride.
Okay, is it? I'm not going to trick my mind to say there is a little bit of difference.
There's a difference there, but if I gave you that one, you wouldn't say it's inherently salty.
Yeah.
To be honest with you, now that I'm taking this one, reminds me of our tap water. Right, the difference between those two, that's our tap water.
Okay, slightly more, but
it's not tasting salty though.
I wouldn't say
but
it's
there's definitely something going on in the palate,
right? Right. Okay. Drink number 4. Okay, we're getting briny.
Yeah. And that one's now. If you tasted this one blind, you'd say that is salty. You even said briny, so you said it before I even got you to it. And then this one, just because it's the kicker.
Oh, great. I'm glad you did a spit take. Here we go. Yeah, that's just not good.
That isn't ocean level yet, but it's
getting there.
Another 1 or 2 dilutions more, or titrations up from there.
Okay, so tell me the ppms of each. If we said this is pretty much close to 0, because we know that.
This, starting from the top down, because I can do the math better this way. This is 1 gram per milliliter, per liter, sorry, which is 1,000 ppm of sodium chloride.
Okay.
So it's 1,000. So this is 1,000, 500, 250, 125.
125.
And then the big jump down to 0.
Yeah.
So at 125, it's not inherently salty, but there is a change in terms of the crispness of this, right?
Yep.
And I think inherently that is and it just so happens that our tap water is about 150 ppm sodium chloride, or chloride and sodium. It's not exactly this, but it's pretty close to this. And I think when you taste these two side by side, you get that sense then of what our tap water actually tastes like. So, and what we're battling when we try to build water chemistry from here. So anyway, so that's pretty good. So your flavor threshold, I think the definitive, it's salty, came in somewhere around 500 ppm?
Yeah, I think so.
Yeah, so probably somewhere between the 250 and 500 is like this threshold for you identifying it as salt.
Yeah.
Table salt, right? Fascinating. So why don't we do it one more time?
Yep. But this time,
why don't you pick, we can do calcium chloride.
Yep.
Or we can try gypsum, which is calcium sulfate. I don't know how well this will dissolve, but what the heck. So
what do you think is going to dissolve better?
Calcium chloride will probably dissolve.
Okay, well, when we try that, because I mean, it'll be
interesting to see if it tastes salty or if you're just getting the chloride effect.
Yeah. Well, I think that
if we have time, we can try both. But we'll do this.
Let's do the calcium chloride, because I think that's going to dissolve better and be a better experiment that goes along with what you did with table salt.
Right. Okay. Great. All right. So we'll pause here. I'll remake these and we'll go for it.
Cool.
Okay.
All right, we're back. And it looks just like the other experiment, but I watched him again, and Science with Mike showed us that he did the same process, but this time with calcium chloride. correct? Mm-hmm. So again, first pour is just good old spring water. Nothing added. Okay, my palate is adjusted. Okay, first one, a little bit different, I guess. And you think that may be able to pull out some sodium in this, but...
Not sodium, but...
Chloride, calcium chloride. Okay, yep.
Something's happening, right?
Something is happening. Oh my God. What is this laced with? No, yeah, it's certainly a different taste experience between 3 and 4. That's when things start to really materialize. Okay. Yeah. Wow. Yeah,
Calcium.
Yeah. That's like...
It's interesting.
Rocky.
Yeah, it's I don't know if it's because we're so used to it, salty taste is like, right? So this is calcium chloride versus sodium chloride. So, but it's really cool just from a science standpoint how different they taste, right? Sodium chloride, table salt. There's a reason why we use that on our food and stuff. Versus calcium chloride, it just doesn't have that saltiness, flavor to it, right? But there's definitely, for me, it's more, until you get to the biggest one, it's more experiential. There's almost like a mouthfeel type of thing happening there. And it's almost, how would you describe it? If you were to put a word for it.
I said kind of, it tastes like rocky but chalky.
Yeah, it tastes almost like chalky. Like there's something about the calcium there. So it's definitely the cation, the calcium, that's having like that flavor impact. Right? Because the chloride's the same in both.
Feels like it's sticking
tongue.
and
it is funny.
mouth.
This one is almost, it's drying almost, and it's bittering to an extent, right? Yeah, it is. Yeah. This one here, the 500 ppm, it's noticeable, but it's not as off-putting.
No.
Just one more jump, it's like pretty strong. Now, for brewing purposes, right, 1,000 ppm, you're just never gonna go there. But some people are making IPA with 300 to 700 ppms of like gypsum, right? So getting up somewhere in between here, let's just think about the calcium for a minute. So of course, if you add in some malt backbone and fruity hop flavors or whatever, it wouldn't be as jarring, but I think you can begin to appreciate that just in the water alone, what that does to you. But I think the jump from down here, I don't begin to really notice it until here. So it's a little bit less potent than there's definitely like something happening on the mouthfeel with sodium chloride right away at 100 and something ppm. But here,
not really with the
I don't get to it till I get to about the 200. So to me, what does that say? What did that say? So
what was the impetus of doing this?
So the question for me with this one, right, is I usually try to add, say, between 50 and 100 ppm of calcium, no matter what I'm doing, just to make sure there's enough in there. But am I actually even making an impact on the flavor quality of the beer? Now, granted, we need to do this maybe with beer or somehow work in like malt, maybe malt tea or something with these waters. But I think it's funny that at 50 ppm of calcium chloride, it's really indistinguishable from the plain stuff. So even if I was making a beer, I can't imagine actually making a pretty big, any impact on your flavor profile. You'd have to at least get up to 100 or more to get some sort of whisper of something going on there. Now that doesn't mean though that the calcium isn't going to react with the phosphates and give you some pH differences.
Everything in there.
But if we're just talking strictly about what's happening post-mash in flavor, even if you were then maybe doing kettle additions of salts to try to impact flavor, it'd be interesting to do a titration like this with, you remember we did a video a long time ago where we added gypsum or table salt to beers and tasted them. If the flavor impact is more sensitive there than it is here. But I think for me, the impetus was that maybe I'm always going to push to a minimum now of 120 or 125, let's say, of calcium something to start, because my palate is insensitive to it below that. Does that make sense?
Yeah.
So anyway.
Interesting stuff.
Funky
stuff, man.
Cool.
Well, a lot of granulated cylinders were used in the making of this video, so you know that some lab.
It's legit.
Yeah, some lab is missing some equipment, but well, I'm not saying anything. I didn't see anything. This is all done out of equipment that Mike has purchased, I'm sure, on the level. So, all right. Well, thanks for watching along. This has been fun for us, I guess, for sure. It was interesting to see just in terms of, you know, where our flavor threshold was with the ppms. 'Cause I think that when it comes to water chemistry, we know that these are levels, but what does that really mean in terms of the end result or in the flavor and or the whole experience of the beer?
Yep.
Looks like Mike's learned something, that he's going to push it up to about 125 ppm of calcium.
And remember, we're talking ppm of total compound, not individual ions, right?
Yes.
When we talk about recipes, when we say 500 ppm of calcium, we're not saying 500 ppm of calcium chloride,
Right.
it's calcium,
Yeah.
right? So this is a little bit different. This
Yep.
is total compound, not ion.
Yep.
But in the case of like sodium chloride, it's pretty close. They're 1-to-1,
Yeah.
right?
Yeah,
So
yeah.
they have different molecular weights. We don't need to get into it, but it's close. It's close.
It's very close. All right. Well, after all this, I need a beer. So
Cleanse that palate.
if you have questions, please leave them in the comments below. If you like this video, give us a thumbs up. We try to do all kinds of different home brewing experiences, experiments, and other knowledge transfers. So please subscribe to our channel. We do this kind of thing every single week. For John and Mike, brew-dudes.com, brew on.
Cheers.